Hello, chemistry students. Today we're going to continue our conversation on solutions, and we're going to talk about rates of dissolution and solubility in this video. First thing you need to know is like dissolves like. Polar and ionic solutes dissolve in polar solvents. Nonpolar solutes dissolve in nonpolar solvents. The rate of dissolution is simply how quickly a solute dissolves or how quickly it can dissolve. Solubility is the amount of solute, remember the thing that you're dissolving is called the solute, that dissolves at a specific temperature. Rate of dissolution and solubility are often confused. They are not the same. The rate of dissolution is how quickly something dissolves. Solubility is the amount that can dissolve. Okay, now let's go through this chart here. So we have dissolution rate of a solid, so how quickly a solid can dissolve. If you heat a solution, it increases. We know that when people make Jell-O, they always heat up the Jell-O before they heat up the water before they dissolve the solid in there, because it makes it dissolve quicker. If you agitate it, that also increases the dissolution rate. You can stir your tea when you add sugar in it, and it will dissolve faster. Or you can stir your Kool-Aid mix, your water in your Kool-Aid mix, and it'll dissolve faster. Or if you add one of those drink mixes into a bottle of water, you typically put the bottle cap back on and shake it. Now, if you increase the surface area of the solute or the thing that you're trying to dissolve, that also increases the rate at which it will dissolve. And increasing the surface area means if you crush or grind it. So if you have a piece of rock salt and you put it in some water, and then you have the same mass of granulated salt and you put it in some water, the granulated salt will dissolve faster because there's more surface area for the water to touch. Now, if you increase surface pressure, that has absolutely no effect on the dissolution rate of a solid. Now let's talk about solubility of solids. If you heat a solution, the solubility of a solid will increase. The amount that you can dissolve will increase almost always. If you agitate the solution, if you stir or shake it, it has no effect, because the amount that can dissolve has absolutely nothing to do with if you stir or shake. Now, the rate at which it will dissolve, how quickly it will, has something to do with that, but it has no effect on how much will dissolve in there. You can't make more sugar dissolve in some water just by agitating it. At some point, it will stop dissolving no matter what you do, as far as shaking or stirring. If you increase the surface area, that has no effect as well. Once it's reached its solubility, it cannot dissolve anymore unless you increase the temperature. If you increase the surface pressure, that also has no effect on the solubility of a solid. Now let's talk about solubility of gases when a gas is dissolved in a liquid. Okay, if you heat your solution, gases have a tendency to come out of solution. Usually people put their Cokes and whatnot in the refrigerator, and the reason why is because it will keep the carbonation in there longer, or at least that was the original reason. Now it may just be because you want it cold. And if you heat it up, it will come out of solution. Now let me tell you this, you cannot typically see a gas that's in solution. It just looks like a homogeneous solution. You cannot see it, but once it comes out, that's when you see the bubbles. That's when it's coming out of solution. It's like a precipitate as far as a solid is concerned. If you see a gas bubble, that means the gas is precipitating out of the solution. Okay, agitating it. If you take a Coke and you shake it up, the gases will come out, so that decreases the solubility of a gas. The gas will come out of solution. You see more bubbles. Increase the surface area of a gas, that has no effect. No effect at all by crushing or grinding gas, which is kind of odd, which you can't do. Increasing surface pressure. Now that will increase the solubility of the gas, which is why all of the soda bottles are under high pressure. You can take a bottle that has not been opened or a can and squeeze it, and it's very difficult to squeeze. But once you open it up, you hear that psst. That's gas or pressure being released out of the bottle, so you're decreasing the pressure. When you do that on a Coke bottle, you can actually see as soon as you open up that can top or that the bottle top, you can see the gases form on the sides of the bottle and come up out of solution. And the reason why is because you're decreasing the pressure, which decreases the solubility of the gas, which means the gas will come out of solution, which is why you see the bubble. Now let's talk about solubility and concentration. First one, an unsaturated solution. This is a solution that contains less dissolved solute than the maximum amount that can be dissolved. So more solute can be dissolved. So it's like, for instance, if I add some sugar to water and I dissolve it, like a tablespoon to a liter of water, I should be able to dissolve it, and it would be an unsaturated solution because I could add another tablespoon and stir it and it will still dissolve. The next type is a saturated solution, and that is the solution that contains the maximum amount of dissolved solute at a given temperature, which means it cannot dissolve any more, and it will typically settle out at the bottom. No more can be dissolved. And lastly, there's the supersaturated. Supersaturated is a solution that contains more than the maximum amount of solute at a given temperature. So it's holding more than it should be able to. Now what happens, in order to make a supersaturated solution, you have to heat it up, because remember, the only thing that can change the solubility of a solid is increase in temperature. So if you want, let's say you need 2 cups of sugar to dissolve in 2 cups of water, and you can't do that at room temperature, but you can if you heated it up. So if you heat it up, then you can get all the sugar to dissolve. And usually that's what they do for sweet tea. They add a lot more sugar than can be dissolved at room temperature, so they supersaturate it by heating it up and then dissolving it. These solutions contain more than the maximum amount that should be dissolved, and they are typically very unstable, which means if they're disturbed, the excess solute will crystallize out of solution. And I'm going to show you guys an example of that in class. Right now, I'd like for you to pause the video and complete the test tube solubility question in your notes. It looks like this. We need to find out which one is supersaturated, which one is saturated, and which one's unsaturated. Here are the answers, and check. Okay, now let's talk about solubility curves. Solubility curves show the dependence of solubility on temperature. So as you can see over here, we have 5 substances, and they are graphed depending on their solubility and at what temperature. So the temperatures change, and that changes how much solute can be dissolved. And this happens to be in water, 100 grams of water. Any amount of solute below the line indicates that the solution is unsaturated at a certain temperature. So let's look at NaCl. Okay, that one's easy. It's the green line. And at 40 degrees C, can I dissolve 20 grams of NaCl? And the answer is, here's the point, and it falls below the line. So that means that a solution that is made at 40 degrees C that has 20 grams of NaCl in 100 grams of water, that solution is unsaturated. Now, if the amount of solute falls on the line, the solution is saturated. So let's look at something different. Let's look at the KClO3, or potassium chlorate. Now, I want to know if at 60 degrees C, 20 grams of potassium chlorate is dissolved in 100 grams of water at 60 degrees C. And if you notice right there, that falls on the line, so that is a saturated solution. which means that if I add another gram of potassium chlorate, it will not dissolve. It will fall to the bottom of the solution and just stay there, and there will always be approximately 1 gram left. Any amount of solute that is above the line in which all of the solute has been dissolved shows that the solution is saturated. So if I say I made a solution of potassium chloride at 50 degrees C and I put 50 grams of potassium chloride, so it would say if I have a solution that contains 50 grams of potassium chloride at 50 degrees C, as you can see the point here, it is above the KCl line, which means it is a supersaturated solution. That solution is supersaturated because it should only be able to hold about 42 grams, but there are 50 grams and it is all dissolved. That's the key there. It has to be all dissolved. Okay, supersaturated solutions, remember, contain more than the maximum amount of solute at a given temperature, and they are unstable. So the extra amount of solute that is precipitated to the bottom is the number of grams that's precipitated is equal to the total number of grams that were in the saturated solution minus the number of grams of a saturated solution at that temperature. Now just write that down somewhere and remember it. We're going to go through an example here in just a minute. Okay, first example. Which substance maintains almost constant solubility over the temperature range? Okay, so that means as we go up in temperature, the solubility has to change very little because it says constant solubility. So which of these lines is flat? Yep, that's right. It would be the sodium chloride. So sodium chloride is the substance that maintains almost constant solubility. Number 2, which substance decreases in solubility? So this decreases in solubility as the temperature increases. So we're looking for a curve or a line that goes down as we increase in temperature because it decreases in solubility. So our solubility must go down. And the only substance that does that is cesium sulfate. Number 3. What is the solubility of potassium chlorate at 60 degrees C? So what we're going to do is we're going to go to 60 degrees C and we're going to go up to the potassium chlorate line, and then we're going to move to the right to find out how many grams can dissolve in 100 grams of water at 60 degrees C. And it appears that it is 20 grams of potassium chlorate can dissolve in 100 grams of water at 60 degrees C. 4. A solution contains 50 grams of calcium chloride in 100 grams of water. So let's plot this point. And it's prepared at 10 degrees C. So at 10 and 50 grams, you will see that it is below the line of the calcium chloride, which means if it's below the line, it is unsaturated. Number 5. A supersaturated solution, that's an indicator right now that the data that we're getting in here is above the line. It's supersaturated. And it's at 10 degrees and it contains 40 grams of potassium chloride. So we're going to go to 10 degrees and 40 grams. And sure enough, it is above the line of KCl. At what temperature was the solution saturated before being cooled to 10 degrees? Okay, in order to make a supersaturated solution, it has to be heated up before it's cooled down because you have to make it dissolve first. And in order to do that, you got to increase the temperature. Once you do that, then you can start lowering the temperature slowly and without disturbing it, and it will stay in solution, which makes it supersaturated. So we need to find out where on the line that 40 grams of KCl can dissolve. So we need to find out where on the line. So we move this 40 grams all the way till we hit the KCl line, and then we go down and see what temperature that's at, and it is 40 degrees. So we had to heat the solution up to 40 degrees, dissolve 40 grams, and then cool it down to 10. 6. If the supersaturated solution in the previous question is disturbed, how many grams of KCl will fall out of solution or precipitate or suddenly crystallize? So we had to heat it up to 40 degrees in order for 40 grams to go into solution. So we have 40 grams in solution. Okay, 40 grams in solution, and we need to subtract the amount that can dissolve at 10 degrees. So at 10 degrees, which is right here, we have 30 grams that should be able to be dissolved, or should be able to dissolve. So we're going to take, and if we shake this solution or we accidentally disturb it, the extra is going to come out of solution. 30 grams will stay in because 30 grams can stay dissolved. So it's just 40 minus 30, and that's equal to 10 grams. So we should have 10 grams of KCl precipitate out of solution.